Yes, you're welcome to today's tutorial. I'm Oluyede Emmanuel Oluseyi from the Department of Chemical Engineering of Ladoke Akintola University. I'll be taking you through Hysys as part of our training and helping people become a very great process engineer. I'll be taking you through Hysys, and I'm in my Hysys interface. As you all know, that the first thing to do is to select your component. So here I am. Can you safely, or before I go any length further, I'd like to show us the question: a stream containing 10% ethane, 30% propane, 50% isobutane, and 10% or 10% normal butane at 50 degrees Fahrenheit and atmospheric pressure, and a flow rate of 100 kilogram mole per hour. This steam is to be compressed to 52 psi and then cooled to 30 degrees Fahrenheit. The resulting vapor and liquid are to be separated as the two product stream, neglecting the pressure drop inside the condenser. Yes, the question is asking us to use this fluid package, and this is the question: what are the flow rates and molar composition of the two product stream? And we are also asked to create a case study to see the effect of changing temperature of the cooler outstream on the molar flow of the liquid product stream. See, from this question, as you can see, I'm going to be needing some equipment, so let's just rush through it. I'm going to be needing a compressor, I'm going to be needing a cooler, and I'm going to be needing a separator. Those are the three unit operation that I will be requiring for this process. So once we know our question like that, we can go back to Hysys and go back to our Hysys interface. You can select your component by clicking Add. So from the question, we have ethane, propane, isobutane, and normal butane. I think they follow each other. Ethane, you can press Ctrl and keep on clicking to select them. So once I'm done with it, ethane, propane, isobutane, and normal butane, I can just click Add. So my component is added already. If you look at this area, it has turned to blue. It was formerly red. It means now that it's blue, my component has been selected successfully. Our fluid package, we have NRST, so I just add my fluid package. Don't forget, fluid package is the thermodynamic property in which you want Hysys to use to solve your problem. So I just, where is it? Okay, it is not, it is NRTL. So it means this fluid package is okay for the simulation. Also, I'd like to show you some things, a guideline. You can read more on thermodynamics to actually know the right fluid package to use for a particular component you are selecting. So I'm done with my fluid package. Is changed to blue too. It means it's okay. And if you look at the property package, okay. So I'm good to go. I don't need petroleum, I say, because I'm not working on petroleum and I'm not working on reactor, so I don't need all of them. So I'll just proceed straight to simulation. There is a one here, one fluid package. So some of the binary coefficient for this fluid package, they will be set to 0. Am I ready to do that? No, I don't think I'm ready to do that. So I can go back to my let's see, I can go back to my property package. I'll go back to my property package. I can set, let's use Peng Robinson. Yes, or we can also use PRSV. I think that's okay, but let's use Peng Robinson for now. So I think it's okay. So I can go back to my, if you go back to the property package, it's changed already. We are using Peng Robinson. So we can go back to our simulation. Here I can add my feed stream by clicking on it and bringing it down here, and I can change the, as you can see, it's still light blue. It means nothing is inputted on it. Hysys does not have any information to calculate this stream yet, so I have to double click on it and change things. So now I can change this one to feed. I can change it to feed. Feed. So let's go back to my question. We have the temperature is 50 degrees Fahrenheit and atmospheric pressure, that's 1 atm. So I can go back to my so I have my 50 degrees Fahrenheit. It is in centigrade for now, so I have to change it to Fahrenheit. So this Fahrenheit, and my pressure is 1 atm, so I can change this to atm, atmospheric pressure. So I can, my molar flow rate is 100 kilogram mole, and I can double click on this to change my mole fraction. Another way of doing it is you going to composition, and you can just, mole fraction is under mole fraction, you can just press this. So a thing, we have 10% of a thing, which is 0.1, so I can tap my 0.1 here, 0.1, so it will bring me to here now. So I can keep on inputting my property. I have 30% propane, 50%, that's 0.3 propane and 0.5 butane, 0.3, 0.3 propane, 0.3 and 0.5. So the remaining should be 0.1 to make the total fraction be 1. So I can click OK. As it has calculated the stream, it is okay, so I can proceed. So let's go back to the question. And the flow rate of this stream is to be compressed. It means I need a compressor now. I need a compressor, so let me just look for compressor here. Compressor, this is a pump, this is a pump coming. Yes, I just look for my compressor, this expander, this compressor. I can click on it and bring it up here. So this is my compressor, so I can double click on it. As you can see, it's still red. There's nothing has been put in it yet, so I have to double click on it. So my inlet should be my feed. Okay, so I can make my outlet to be compressor out. Yes, and energy to be Q compressor. I can change the name to compressor. Yeah, let me just leave it that way. So if you check here, Hysys is telling me that unknown duty, so I have to go to my parameters. I have to input some things. So this is the efficiency. I'm going to leave it at 75%. Yeah, we have delta P specification. So let's just go back to our question and see what the compressor should do. The steam is to be compressed to 52 psi and then cooled to 30 degrees Fahrenheit. So it means I can't do anything here for now, so I can just close this, and this is my compressor out. This is the stream that is going out. and the question is telling us that we have to compress this stream to 52 psia. Yeah, so as you can see, I've calculated, Hysys has calculated it, and okay, let me show you something first. So under prayer we inputted, so let me just delete this and press OK. Yeah, look, when we were inside this place, it's telling me unknown duty, and it means I know the change in prayer. I can just input my change in prayer and Hysys will calculate it out, but I don't know my change in prayer because the question is telling me to compress the outlet stream to 52 psia. So what am I just going to do? I can't do anything inside the compressor. I can just go to the stream that is going out. Since I know the value I want, the value of the pressure that I want, Hysys has calculated almost every other thing. You see all those things in black, it's been calculated by Hysys, but I need to specify this. The pressure, the outlet pressure. So and we're asked to make it 52 psi. That's why I have to click on that outlet stream, which we name our compressor out, and change it to 52 psia. So change it to 52 psia, the stream will be calculated. Thereby Hysys we can calculate our compressor too. So I can close this. This is done. Our compressor is done. We now have, if you look at your screen, you will have our delta T to be equals to 49.15, and our delta P, that is change in pressure. The change in pressure is 257.2 kilopascal, and our molar flow rate is 100 kilomole per hour. So we can move further. Let's check our question again. I hope you are following me, and I hope you are getting it. I want you to follow me very well. I want you to listen attentively as I'm doing it, so that you can replicate it and you can do yours as well. So this stream is to be compressed to 52 psi. We've done that, and then cooled to 30 degrees Fahrenheit. It means I need a cooler, I need a chiller. So I have to bring my chiller. I have to bring my chiller. This is an heater, this is a cooler, so I have to bring my cooler here. I was told this stream, the temperature is 59.15, that is 138.5 degrees Fahrenheit. So I want to cool 138.5 degrees Fahrenheit. I want to cool it to what? We have to cool it to 30 degrees Fahrenheit. So I have to, I can change the name to chiller. Yes. What will be my inlet stream? My inlet stream will be my comp out. So I can just click on the inlet, comp out. I can make my outlet to be chill out. So as you can see, as I wrote chill out, Hysys has already added it for you here. So another way of doing this is you can close this. Another way of doing this is you can bring a stream here and put it here, and double click here, and double click here and select here and choose chill out. So that's another way of doing it. So the Hysys is telling me that it requires an energy stream, so I need to input my energy stream. Now I can call this Q chill, that is the energy of the chiller. So, and it's telling me unknown delta P. I don't know the delta P too, but I want my Hysys to calculate it out for me, since I know the temperature in which I want my outlet stream to be. So I can just close that and double click on my chill out. So the temperature from the question is 30 degrees Fahrenheit. So I just click on temperature here and input my 30. I can change this one from degrees centigrade to Fahrenheit. So the chiller is asking me that I need to input my pressure. So let's go to yeah, let's go to our question. It seems there is no change in prayer, so I'll just go here. I can double click on this. I double click on this, there's no change in prayer, so I can go to my parameters and make my change in prayer to be equal to 0. As you can see, as it has calculated it, it's done it. It's writing okay here. So I can close this and close this, and if you look at here, it is writing completed. Okay, so I'm done with that. So let's go back to our question again. After it is being cooled to 30 degrees Fahrenheit, the resulting vapor liquid are to be separated as the two product stream. Yes, let me just check this stream out and let's see the properties. It means in this stream, we have both liquid phase and vapor phase. We have both liquid phase and vapor phase. We have both liquid phase and vapor phase. So we want to separate both of them. We don't want them to be together. I want to separate it together. We want to separate it. So I need a separator. This is a separator. You can just click on the separator. Separator is very easy to model. So all you have to do is just bring it here and double click. You double click on it, it will bring up the interface. So the inlet into the separator will be our chill out. Our chill out is going in. So let me bring this back. I can just bring my chill out. I can make this my vapor products. I can make this my liquid products. So I've done that, and Hysys has already calculated the stuff for me, so there is no change in prayer. We should check the question. Neglecting prayer drop inside the condenser. It means we are not going to be dealing with any change in prayer there, and Hysys has calculated it for us. So I can close this. I've solved what I needed to solve. This will be in vapor. The vapor fraction here is 1. There's no liquid phase. Liquid phase is 0. And if I close this too, there won't be vapor phase. You see that vapor fraction is 0 and liquid fraction will be 1. Liquid phase will be 1. So I've been able to separate my my vapor and liquid, So the next thing, let's check the question and see what the question wants us to do. What are the flow rate and molar composition of the two product stream? So you can check that using your workbook. Our product stream is vapor product and liquid product. So you can just check that and check the composition. This is the composition. Using the workbook, you can see the property of all the streams. The feed, the comp out, the chill out, the product stream. So that's just it. I can go back to my main. If I want to check for only vapor product, I'll just double click on it. It will bring the tab for vapor product alone, and I can check my flow rate. My molar flow rate is 10.30 kilomole per hour, and cool like that. I can check the composition. I have 0.3%, 0.3625 of ethane, propane to be 0.3655, and 0. Like that. So you can check your results The condenser too, you have the duty to be equals to 2.23 times 10 raised to the power 6 kilojoule per hour. So Hysys has calculated everything for you. So we are good to go to the next thing. So we are asked to create a case study to see the effect of changing the temperature of the chill out on molar flow rate of the liquid product stream, and write your comments. So let's just quickly create a case study. So I can just click on my case study tab. So my case study has opened. I can click on add. So after clicking on add, I can excuse me. So after clicking on add, I can add here. So what are we asked to vary? Yeah, we're asked to find the effect of changing the temperature of the cooler out, that is the chill out, on the molar flow rate. Yeah. So now my chill out, this is my chill out, this is my chill out. I want to vary the temperature of it. So let's look for temperature here. Let's look for temperature here. So let's look for temperature. You can just scroll and look for the temperature. I think this is arranged in alphabetical order, so we are in P, so we are here to get to T. So this is temperature. I can just click on temperature and say okay. So I can just click add again. Click add again. So I can just click, what's the name of my, okay, let me cancel this. Let me go to the main. So we are asked to find the effect on the liquid products. So let me go back to my case study. So I can add again, but add again. So liquid products, no, V100, okay, this is my liquid product, I'm sorry. So we are asked to find the effect of temperature on what? On the molar flow of liquid product, on the molar flow of liquid product. So I just go to my molar flow. I'm trying to look for molar flow. Yeah, I think I'm almost there. Yes, molar flow, and I can just click OK. So this is our independent variable, and this is our dependent variable. You can see that under independent variable, this is writing yes for this and it's writing no for this. So this is the independent variable and this is the dependent variable. The dependent variable is the value that we are trying to check how this is changing, you know. From, if I say y equals to 2x squared plus 3x plus 6, x is the independent variable because it is the value that you know, but y is the dependent variable because the value of y will depend on the value of x. So therefore the molar flow rate will depend on the value of temperature. So since I've had everything like this, so I can just change my temperature. So let's just see, let me go back to my main flow sheet, my chill out. Let me see the temperature here. The temperature is minus 1.11 degree Fahrenheit. So okay, there's no need of I can just close this and I'll go back to my case study again. So my chill out temperature, the lower band, I can make this one to be equals to like 1 degree C, and my high band to be 50 degrees C. So the step size, okay, let me make this to be equals to 0. I just change it to be 0 and my step size to be equals to 5 degrees C. So I can just click on run. So as I click on run, as you can see, this changed to success. It means my case study is done. So I have my results already, so I can just go to results of the case study. So let's now see the results. This is the beauty of case study. You tend to see the value that you get at each temperature. Now if the temperature of my chill out, if the temperature of this chill out, if it is 0 degrees C, the molar flow rate of liquid product will be 87.14. If the temperature is 5 degrees C, the molar flow rate will be 72.24. If it is 10 degrees C, the molar flow rate is 49.82. So increasing this by 5. When it gets to 15 degrees C, I have my molar flow rate to be equals to 13.58. But when it reaches 20 degrees C, every of my product is now in vapor phase. There's nothing, I don't have liquid phase again. Everything is vapor. That's why you see that the liquid molar flow is 0. And for every temperature above 20 degrees C, all my components will be in vapor phase. So that's the beauty of case study. It helps you to make a logical conclusion. It helps you to know your possible result. If you don't want to tamper with your simulation, you can just do a case study and check and compare results. That's the beauty of simulation. So this table, I can ask the Hysys to plot it for me by just clicking on plot. So if I should click on plot, yeah, this is the plot. This is the plot. At 0 degrees C, my molar flow is somewhere here, which is 80 something. At 5 degrees C, my molar flow rate is here. At 10 degrees C, my molar flow rate is here. At 15 degrees C, my molar flow rate is here. At 20 degrees C, I don't have any molar flow rate again, and it goes parallel like that. So that's the beauty of using case study. I can close this. Now I have my Hysys has solved everything for me. Now I hope you've been able to gain one or two things from this tutorial. If you love this tutorial, I'd like you to just subscribe to my YouTube channel in which you are watching this, and you can watch some subsequent videos. I hope to see you some other time when we'll be doing some other simulation in building your knowledge of Hysys. Thank you once again for listening. I'm still myself, Oloyede Emmanuel Oluseyi, from the Department of Chemical Engineering of Ladoke Akintola University of Technology. For more information, you can just call me on 08136366883. I will take that once again, 08136366883. Thank you. See you some other time.